In this lesson, we will discuss how to rethink the built environment from a sustainability perspective, providing an overview of the technologies and solutions that we can adopt in the context of contemporary city architecture. First of all, we need to understand what the built environment is. The built environment encompasses all the physical spaces created, modified, and organized by humans for living, working, moving, and interacting. It includes buildings and open spaces, both public and private, such as squares, parks, streets, courtyards, and associated areas. We can equate it with the concept of a city or metropolis, as well as with smaller towns. And what do we mean by the term sustainability? The concept of sustainability emerged in 1972 with the report The Limits to Growth by the Club of Rome, which warned about the risks of unlimited growth. The Brundtland Report of 1987 defines sustainable development as development that meets the needs of the present without compromising the ability of future generations to meet their own needs. There have been many steps taken towards sustainable development, and even today there is still a long way to go. The built environment bears a great responsibility in terms of greenhouse gas emissions, consumption of natural resources, and waste production. To fully understand these impacts, it is essential to adopt a perspective that considers the entire life cycle of built structures, starting from the production phase of building materials and components to the construction phase, including the transportation of materials to the site, the usage phase with the consumption of energy and water resources during the operation of our homes, offices, and services, and finally to the end-of-life phase with the generation of waste. These impacts are particularly significant in urbanized areas, where the majority of the population and human activities are concentrated. In fact, more than half of the current population lives in urbanized areas, and according to a 2019 United Nations report, this percentage will rise to 70% by 2050. These environments, which also concentrate economic activities and services, are experiencing the direct and indirect effects of the climate and environmental crisis we are facing, in terms of risks to the safety and health of the population, security of supplies, and also increased costs to cope with emergency conditions. In cities, the negative impacts of climate change can be amplified by microclimatic phenomena, such as the urban heat island effect, that is, the local overheating of an urban area caused by the morphological and material characteristics of the built environment. So how can we rethink the built environment to make it more sustainable by reducing the impacts it generates? And how can we make it more capable of adapting to ongoing climate change? To answer this question, in 2022, the Envireg Research Group from the ABC department of the Politecnico di Milano conducted a study identifying specific objectives and corresponding technical solutions to pursue in the design of the built environment. Among the objectives identified were regulating the urban microclimate, improving air quality, sustainable management of stormwater, reducing energy consumption and CO2 emissions, and minimizing environmental impact by considering the entire life cycle of buildings. In order to regulate the microclimatic conditions of a built environment, it is necessary to implement solutions that can be applied at the building scale as well as at the district and entire city level, with reference to the following strategies: increasing the shading of surfaces through the addition of trees, pergolas, tensile structures, and lightweight coverings. To shade building facades, it is possible to plant trees near the buildings and to install vertical greenery systems. Control the temperature of surfaces by using artificial materials with high solar reflectance, permeable surfaces, or combined cooled paving systems. Control air temperature and humidity by increasing green areas and using water-based solutions such as biobasins, rain gardens, infiltration basins, retention ponds, wetlands, water features, fountains, and misting systems. Promote microventilation through the spatial configuration of buildings and green areas in relation to local winds. To improve air quality, it is recommended to provide an adequate amount of green spaces and green technological systems, such as tree plantings, hedges, vegetative systems, and nature-based solutions applied at the building scale, like green walls and green roofs. Alternatively, use absorbent materials for facade cladding, such as photocatalytic materials and nanotechnological materials. To sustainably manage rainwater in the built environment, it is possible to increase the permeability of paved surfaces by providing green areas, natural infiltration systems, and permeable artificial pavements. For example, grassed concrete grids, grassed plastic grids, unpaved surfaces, porous pavers, and permeable concretes and asphalts. Delay the conveyance of rainwater into the sewer system during heavy rainfall events by using natural infiltration systems or artificial retention systems such as rain plazas and by creating green roofs on buildings. To reduce energy consumption, it is essential to apply the principles of bioclimatic architecture by designing with the climate in mind. This means taking into account solar radiation, potential sources of heat loss, shading, and wind flows. Undoubtedly, reducing energy consumption also involves the use of specific technologies for the design of the building envelope. For example, consider the various thermal insulation technologies. The goal of producing energy from renewable sources is becoming increasingly central. The use of photovoltaic panels and micro or mini wind turbines for electricity production, solar panels for heating domestic hot water, and geothermal heat pumps for heating and cooling indoor spaces is becoming increasingly widespread and more easily integrated at both the building and urban district scale. To reduce the environmental impact of the built environment, considering the entire life cycle of buildings, it is possible to promote the reuse of existing assets or encourage the reuse of building materials and components. Use low environmental impact materials with high recycled content and that are recyclable at the end of their life. Use local materials, durable and low maintenance materials, and materials with EPD environmental certification. Apply construction solutions with low environmental impact such as dry assembled and disassemblable technologies. Use stratifications whose layers are made of a single material and employ prefabricated construction solutions. In this lesson, we have covered only the main technologies and solutions that we can apply in urban architectural design to make the built environment more sustainable. The environmental and climate challenge strongly calls attention to the great social responsibility that we, as designers, have and will increasingly have in the future.